Hello, I'm Dan Ridley-Ellis, and I'm going to talk a little bit about timber strength grading and how that can sometimes get in the way of the circular economy. Now, we need to change the way that we think about wood as a green construction material. It's often said that wood is abundant because it's renewable. But renewable is not the same as infinite. At any particular time, we have a limited supply of wood and actually a limited capacity to grow new timber too. And with rising global demand, there will be increasing pressure on that limited supply. We also tend to think that we can continue to focus on just a few main commercial species, but in reality that's not going to be all that sustainable in the future either, because we need to build resilience into the forest against pests and diseases and climate change, and resilience comes from having a wider range of species. This also tends to be what the public want from the forests as well. They're not so happy with just having one species in there as a commercial crop. And we also tend to think that we can continue to expect rising quality and constant low prices. And with rising global demand for timber, don't think we can continue to expect that those two things will continue into the long run. We also tend to think that certification and sequestered CO2 are the only two things that matter when it comes to environmental impact of timber construction. In fact, we might even be saying that the more wood in the building, the better, because the more wood, the more sequestered CO2. But there you're not really thinking about the impact of timber being of limited supply, that there is only a limited amount of timber and we need to be more sensible about how we use it. There is also this drive to modernise construction, and in this drive to modernise construction we kind of go a little bit backwards on grading, and we tend to forget a bit about actually what grading is there for. So this is how grading used to be done in the past. We would start with a particular timber source, a particular species and origin and grading method, and we would do the structural design on the basis of knowing the material that we were going to use. But this is a problem in the modern world because you need to know the timber source before you use it, and that's not very good for open trade and having a lot of options for what timber, a lot of options for where to buy your timber from. So we move to the system here where we have, as an intermediate step, these commodity strength classes, and you do your structural design on the basis of a commodity strength class, and you don't specify the species and the origin of the grading method, you just specify the strength class. And that strength class can be met by several different options. Several different species, origins, grading methods will achieve that strength class. So the advantage of that is that you don't need to know your timber source. So you have many options as to where you get your timber from. But this tends to produce a few problems, some of them just in our heads, in the way that we think about grading. So this is how grading is done currently. The harmonised standard is EN 14081, and that's the grading of sawn timber of rectangular cross-section. Now this is unmodified, untreated timber. This is limited in the scope of the standard. The only treatment that's allowed is preservative treatment, because they don't know the effects of other treatments on the mechanical properties, the structural properties of the wood. And that includes also chemically modified and thermally modified timber. They're excluded from the grading. Because we don't know, at the moment, we don't know how to grade them according to the current way that we grade timber. Which is a problem, because that means there's a barrier to those modified timber products replacing perhaps more unsustainable tropical timber sources. So the grading is based on knowing the species and the growth area. Those can be quite broad specifications, but they still need to be known. And regrading is not allowed unless the effect of that first grading is accounted for, which is in most cases very difficult to do. And the basis of the grading is an extensive testing program. So some of the problems that we have with that system: one is knowing the species and the origin of recovered timber. You might have a good guess, but in reality that would be pretty difficult. But even if you did know that, you wouldn't be able to know how it was originally graded and be able to have enough information about that to be able to account for it in the way that we do grading. So even if you did know the species and the origin, you don't know how it was graded or what happened to it in that time. And even if you did, we don't know that this would be guaranteed to work anyway, because something might have changed in the wood over time. It might have degraded, or the properties might have changed with age, or it might have been actually different to begin with too, because the timber quality was different in the past. And this is also a barrier for underutilized and minor species, because it's expensive to bring them into the system because of this requirement for a large initial testing program. So some more problems. One is around how we declare the design properties. So in the construction products regulation, there is something called the Declaration of Performance, which is what contains, lists the design values for your construction product. Now for timber, we usually, for convenience, we just specify EN 338 strength class. It's a simple way of declaring the key things from the Declaration of Performance. So it's like a shorthand for declaring the design properties. But that leads people to think that grading is about the strength class, but it's not. The strength class is just a convenient way of declaring the properties. And although there are quite a few strength classes listed in EN 338, you will not be able to get most of them on the open market. And the reason for this is that, firstly, sawmills produce for the mass market, so they go for the strength classes that people are asking for, that most people ask for. But also builders want to simplify their designs and their construction, so even though their design might be possible to have different strength classes in it, they will tend to specify just one or two, just to make life simple, so that they don't have to deal with different grades in the construction process. They just build everything out of the single resource of wood that they've got. And everyone else in the supply chain is the same. They don't want the hassle of having different stacks and bins, and that's why now there is just a small number of strength classes on the open market. So yet more problems. One is that people tend to think that these strength classes are synonymous with the word structural timber. So in the UK, because people are used to using imported timber, and imported timber tends to be C24, C24 becomes in their minds synonymous with structural timber. They think that C24 is what you need for construction, even if lower strength class is perfectly fine. I'll just specify C24 because that's what they think of when they think of structural timber. So that leads to a big over-specification problem, which is an issue because it costs money, but also because it's a bit wasteful of the material as well. And it rules out many suitable sources, this over-specification problem. The other issue is that the strength classes, well, they fit quite well to the actual properties of long-established species, but they don't fit awfully well to many of the others. What do I mean by that? Well, strength classes, they have three primary properties: strength, stiffness, and density. And in order to put timber into one of those strength classes, all three of those properties need to meet the minimum requirements of that strength class. But in many cases it will be one property, one particular property that actually limits, and the others might be higher than that. Now for spruce and pine and fir, they fit quite well, but for other species you might have one property, one particular property that really drags it down, and the others are way above what's required for that strength class. And often timber will be rejected because it doesn't have the required performance in a property that actually doesn't matter in practice. And I'll talk a little bit about that in a moment. So what do I mean? Well, you have these commodity strength classes, and strength classes are convenient for easy trade. The price for that is that you throw away some of the actual potential of the timber. So, for example here, British spruce. British spruce is limited in a single grade reject. It's limited to C16 because of its stiffness. The strength is a bit higher than C16 requires, and the density is also a bit higher than C16 requires. And British spruce tends to be used for products like wall studs, and wall studs, the stiffness is not so important as the density for connections and the strength. So actually you are limiting to grading because of stiffness, but stiffness is not the key property for the design. This is the price of having commodity strength class. For larch it's a bit worse actually. For UK grown larch it's the stiffness and the strength that limit, but the density is way above what the strength class limits it to. So the strength class for a single grade reject tends to be about C22, but the density is way higher. It's up at the requirement for C35. So you throw away a lot of the potential of the density there. And that means that you discard performance. So the price of this convenient open trade is throwing away some of the potential of the timber, which is fine if you are just using the open market and you're using that advantage. But if you are using, like if you're grading timber yourself for your own use, it doesn't often make sense to go for one of these commodity strength classes, because you don't need that convenience of trade. So why do you throw away some of that potential? And this is true also for, say, grading particular timber for a particular building, or even in situ assessment of buildings. Often we will be thinking in terms of these commodity grades, and that doesn't make a lot of sense when you don't need the commodity grade, because you do throw away some of the performance potential of the timber. And this is a particular problem for density, because density is what governs your connection design, and connection design is often what governs the member sizes. So here in these examples for larch, C16, C27 double grade example, we throw away a lot of the potential of the density in both cases. So the connection design will be much worse than the timber actually is capable of doing. And in fact, it might even be worse than that, because C27 is not a commonly specified grade. The market tends to ask for a grade like C24, so you might grade to C27 but then actually sell it as C24 and use it as C24. And if you're doing that, you're throwing away some of the potential for strength, some of the potential for stiffness, and some of the potential for density as well. So what about the circular economy? Well, firstly, you can't grade recovered wood to EN 14081 because you don't know the species and the origin, and you certainly don't know how it was originally graded. And if you can't grade it to EN 14081, well, you can't do your design, strictly speaking. You can't do your design to Eurocode 5, because Eurocode 5 says you must have graded timber to EN 14081. And you also can't make glue lime or cross lime to the harmonised standard, because they also say you must grade your timber to EN 14081. Now, if you're using recovered timber and it has been graded before, you could potentially just look at the grade stamp if there is one. But firstly, how can you trust that something hasn't changed in that grading to make sure that well, how can you be sure that what's written on the timber is still true? So something might have happened to the wood, including a change in cross-section. So even though the grade stamp is there, it's not a guarantee that you'd be able to trust the information that's on the wood if you were wanting to use it again. So in summary, grading as it works right now tends to hinder the bio-based circular economy for recovered wood, for having a wider range of timber sources and timber species in your construction, and also for more efficient use of the main commercial species too. But perhaps more importantly, it tends to influence the way that we think and behave, and that really gets in the way of the circular economy. So there is a big problem with overspecification, and there's a big problem as well with not using timber to its full potential, because we get to think that we have to use these commodity grades, and because when we use a commodity grade, often we throw away potential in some of the particular properties, then we throw away some of the performance of that timber. Alternative summary is that there are some existing and emerging tech that allows assessment of wood quality earlier in the chain, and that also has the potential to reinvent grading. So we can improve grading by making it more compatible with recovered wood, and that's our aim for this Future Wood project. But by doing so, you might also make it easier to use a wider range of different timber sources and different species. But also, you'd be able to adapt to changes in silviculture and climate for your main commercial species too, because they also change. The properties of the main commercial species is changing as well because of the forest management, because of tree breeding, tree selection, and climate change. And to allow for things that people already do but shouldn't do, it's quite common for people to visually grade rejected timber from machine grading. They shouldn't do it, but some people tend to. So it'd be nice if we did have a system that allowed people to do these things, because clearly there's a demand for being able to do it. And we can also reduce the need for using commodity strength classes. So they won't go away, they're very convenient for the open market, but in a lot of cases there is no requirement to use the commodity strength classes, and it would be a lot more sensible to go for a bespoke strength class that actually matches the properties of the timber that you're using. And the key thing to remember is quality always depends on the end use. So we tend to talk about quality, but quality is always in context. So there's no such thing as bad timber and good timber, it's just how you use it appropriately. And ask why more often. So why is the standard like this? Why am I limited to doing like this? Because often the answer is, well, you're not. In reality, you're not limited. It's just that you thought you were. Thank you for listening.